Okay, so welcome back to another video on this 5-a-day GCSE Maths series. This is 13th Jan, and we are doing the grade 8, grade 9 questions. First one is from ratios, and they've given us an equation. So when they say find the ratio x to y, now, when you have a ratio x to y, you can also represent this in the form x over y. I'm not saying it is equal to x over y. We're saying it could be represented in the form x over y, just for calculation purposes. So what we're trying to find is, what is x over y equal to? So we've got 6x plus 4y is equal to 7y minus x. So let's collect all the x terms on one side and the y terms on the other side. So kick the 4y to the other side, so that becomes a minus 4y there, and it's gone from here. And then you would bring the minus x to the other side, so it becomes a plus x here, and it's gone from this side. So 6x plus 7x, that becomes 7x equal to, this would be 3y. And I need to find what is x over y equal to. So if I divide both sides y, I get 7x over y is equal to 3, or x over y is equal to 3 over 7. That means x over y is equal to 3 over 7. Hence, the ratio x to y is 3:7. Next question, we need to solve a quadratic inequality. So quadratic inequality, first step is to factorize this. So if I were to factorize, I would get x minus 1 and x minus 4, and that is greater than 0. Step number 2 is to draw a diagram. So I've got 1 and I've got 4. Where did I get these from? Because those are the critical points. When you flip these numbers, you get those two. Now the diagram, we know it is a positive quadratic, so it goes up. Now when you read this, I want you to think, how do you read this inequality? X squared minus 5x plus 4, we would read this as greater than. So just add the word greater than sea level. So think of your x-axis as your sea level. So you want it to be greater than sea level, which means you're going this way and you're going that way. So because you're going to the right, that means we're considering this and we're considering that in terms of the numbers. So this would be x is greater than 4, or if you're going to the left, that means we're saying x is less than 1. So your numbers or your inequality is x is greater than 4 towards the right, or we're going x is less than 1 towards the left. The next question that we've got, Pythagoras question. So that's really easy. All we've got to do is take the square root 12, square that, take the square root 30, square that, and that would be equal to your c squared or your x squared. Square root of 12, when you square that, that's 12. Square root of 30, when you square that, that's 30. So that's x squared, which is equal to 42. So you could say x is equal to square root 42. Next one is an interesting question. So we need to work out what is the value of time. All we know is the average speed is 5.96. So first thing that you need to remember is, what is average speed? Average speed is total distance over total time. What is the total time? Total time is, you've taken t seconds to complete the journey. So I know total time is t. Now, do I know the total distance? Well, I don't know, but I can find out. What is the technique? When you have a speed time graph, so this is speed and you have time, the area under the speed time graph would be equal to the distance that you have traveled. So I need to work out this area, this area, this area. That would give me my total distance. So the first shape that I have is a rectangle. I know the base of that rectangle is 7 and the height of that rectangle is 10. So 7 times 10, I would get this is 70. Then I have a trapezium. The base of that trapezium runs from 7 to 12, which means it is only 5. Please do not write that as 12. Many people tend to make that mistake when they see 12. Oh, that's 12. No, that's not 12. The base of that trapezium is only 5 because it's from 7 to 12. Then the height of that trapezium, I've got two heights. The height on the left is 10, which is the taller one. And the height on the right is a smaller one, which is 6. Where do I get these numbers from? Because if you look at the coordinate, or if you look at this thing here, you should be able to see that the height is. So if it was a rectangle, I would have done base times height. But here, I am going to do that. I'm going to do, so the base of the rectangle is 5. And in place of height, I've got two different heights. So what am I going to do? I'm going to find the middle of those two heights. So 10 plus 6 over 2, that's 8. So I'm going to find the middle height. I'm not using the 10, I'm not using the 6, I'm using the middle value. So 5 times 8, that gives me 40. So I've got 70, I've got 40. The next one is I've got a triangle. So if I use that triangle, the base of that triangle is, oh, that's a good question. Is it T? No, it's T take away 12. Because remember, how did we get the 5 here? We did 12 take away 7. That's how we got the 5. So this one we're going to do T take away 12. That's the base. And the height of that triangle is 6. So we're going to do half base times height. So that's half times 6 times T minus 12. So that's 3 lots of T minus 12, which is, so the area of the triangle is 3T take away 36. So this is 3T take away 36. So if I add all the distances together, I have 70, I have 40, then I have 3T take away 36. So that's 110 take away 36, which is 74. So the total distance that I have is 3T plus 74. So I found an expression for the average speed, which is 3T add 74 over T. However, I do know the average speed is equal to 5.96. Which means I could now form an equation. I could multiply this t onto the numerator on the left, so I get 3t plus 74 is equal to 5.96t. So I could kick this 3t onto the other side, so it becomes minus 3t, and it's gone from there. So we now have 74 is equal to 2.96t. And if I divide 74 with 2.96, t is equal to 25. That's my answer. Last part is find the rate of deceleration. Find the rate of deceleration from 12 to, we know t is 25. So remember, in a speed time graph, so if you have a speed time graph, if you take the gradient of a speed time graph, that gives you acceleration. And if it's a negative gradient, that is your deceleration. Positive gradient is acceleration, negative gradient is deceleration. If you have a distance time graph, and if you find your gradient on a distance time graph, that gives you your speed, or it could be your velocity if it is a displacement time graph. So what we need is we need to find the gradient from 12 to 25. So this point right here, that is x coordinate is 25, y coordinate is 0 because I've hit the x-axis. So I need to find the gradient between the 2 points. So I'm finding the gradient between the 2 points, 12, 6, which is at the top, and I'm finding the gradient between that and 25, 0. So if you want to find the gradient, that will be y2 minus y1 take away x2 minus x1. So that's 0 take away 6 over 25 take away 12. So that would be negative 6 over 13. If you want, you can convert that to a decimal. Even if you don't, that's still correct. So negative 6 over 13. And because it's deceleration, it would be meter per second squared. So that's the answer for that. And if you have any questions or if you have any doubts, you can comment or you can ask them in the lesson. I'll see you in another video.